In this video, we are going to graph linear equations by plotting points. So we're going to make what's called a t-table here. These are going to be my x values, and these are going to be my y values. And I'm going to just pick some x values. If I don't have any better x values to pick, I'm going to pick -2, -1, 0, 1, and 2. I really only need 2 points to determine the line, but the more points that I get, usually the better my line is going to look when I connect the dots. So -2 minus 5 is a -7, -1 minus 5 is a -6, 0 minus 5 is a -5, 1 minus 5 is -4, and 2 minus 5 is -3. So let's put these points on my graph paper. -2, -7 is there. -1, -6 is there. 0 minus 5, -5 is there. 1, -4 is there. And 2, -3 is there. And you see the line that is formed here. We put an arrow on the end to show that it keeps going forever and ever that way. We put a arrow on this end to show that it keeps going forever and ever that way. You remember from geometry class probably that lines go infinitely in both directions. So there we go. All you'll need in my labs to be able to draw this line is any two of those points. You'll use your line tool, and you'll start with one point, and then you'll go to the next point, and it'll just draw the line for you. But if you're drawing these by hand, you'll probably want a straight edge, not necessarily a ruler, but something with a straight edge that you can use to connect the dots and make your line straight. Since I don't have a straight edge to draw on my computer here, then my lines may get a little wiggly here and there as my hand shakes, but you get the idea. 0, 1, 2, -1, -2, x, y. And we have -2 times 5 is -10, -10 minus 3 can be -13. That's going to be off my graph paper, so I'm not going to use that one. -1 times 5 is -5 minus 3 is -8. 5 times 0 is 0 minus 3 is -3. 5 times 1 is 5. 5 minus 3 is 2. 2 times 5 is 10. 10 minus 3 is 7. I could go for another point if I needed to, but just at this point I'm going to ignore because it's not on my graph paper. Let's use the points that I have: -1, -8. Right there. And then 0, -3. 1, 2. And 2, 7. There. That should form a line. Again, if we had a straight edge, that would look a lot better, but it's a much steeper line because the slope, when we get to slope, I think next time you'll see this slope is 5, and this slope was only 1. So this one was 5 times steeper. We're going to get a line here that has a fraction for a slope, so it's going to be less steep. And I'm going to give you a hint on how to deal with this one that has a fraction for the slope. Is I'm going to choose multiples of this number for my x value since I get to choose x. So this time, because I don't want any fractions, I don't want to have to graph between points here. I'm going to choose 0, but then the next point that I'm going to choose is going to be 3. and then 6, and I want -3 and -6, so that I'm choosing multiples of 3 this denominator. That way the 3 will cancel out with the multiple of 3 and give me an integer value to add to another integer value, and I'll get an integer, and it'll fall right on my grid coordinates. So a third of -6 is -2, and -2 minus 4 is -6. A third of -3 is -1, and -1 minus 4 is -5. A third of 0 is 0. 0 minus 4 is -4. A third of 3 is 1. 1 minus 4 is -3. And a third of 6 is 2. And 2 minus 4 is a -2. So -6, -6 should be right there. And then -3, -5 should be right there. And then 0, -4 should be there. And 3, -3 should be there. And 6, -2 should be there. And so on. But I'm going to rise 1 and run 3 each time. One, 2, 3, right here. Right? And again, you see that's a much shallower slope, not quite as steep. Sorry, my line's not right there. Like I said, I don't have a straight edge, but you get the idea, and you don't have to worry about that in my labs because it's going to draw it perfectly for you. So that's it for this video. Next time we are going to come back and we are going to graph linear equations by using the x and y intercepts, which are a couple of special points. The x-intercept is going to be when y equals 0, and the y-intercept is going to be when x equals 0. So typically we do that when the equations are written this way, with all the variables on one side and all the constants on the other. And there's a special thing that we look for usually that helps us know that, hey, this equation is easy to graph this way with the intercept method. We will talk about that next time.